Hello people, welcome back. And in this session, we are going to learn about how to perform the one sample Z test. So there are some conditions which I explained you in my previous session that when to perform one sample Z test. One sample Z test we perform when you are comparing the mean against a known average value. So sample mean you are calculating against a known value of the average. You are comparing that either they are same or they are not same, and you have standard deviation as a known value, which means many a time you will see the client will be asking, okay, I want to compare the target value, or you should be meeting the target average value, but your standard deviation should not be out of the or not be greater than the x value. So you are not just comparing the average value, but you have to consider your standard deviation as well. So in this case, because the previous test, which is one sample t test, only explain you comparing the average value. But what we do in the one sample z test, we compare the average value, but the same time we consider the standard deviation as well. So then we perform the one sample z test. What are the things in the one sample z test? Let's learn. So the one sample Z test is a parametric, which means for the normal data procedure for hypothesis testing, especially for comparing a sample mean to a known population mean when the population standard deviation is known. Population standard deviation means you have a target variation as well. That variation should be this or less than this. You should not be crossing that. So this test assume that the population follows a standard normal distribution, and that's how for the normal distribution we call is a parametric test. And then mean and the standard deviation of the population are known. So one sample Z test is similar to the one sample T test or student T test, which we learned in the last session, but is used for relatively large sample when you have a greater than 30 sample. Because the measure of variation generally for a small set of the data we use as a range, but when you have a large set of data, we must take standard deviation as the measure of variation. So this assumes that the population standard deviation is known. So to perform the one sample Z test, we follow these three steps. One, you need to select the appropriate test statistics. Either you are looking for one-sided comparison or both the side comparison, which means one-tailed or two-tailed. Then we determine the null and the alternate hypothesis. We determine the level of significance like 95% or maybe 90% or 99%. And then we calculate the critical value by calculating the test statistics. And test statistic can be calculated, which is the critical value here, by the mean minus mean, which is the target value what you have. And the observation, the mean difference divided by the standard deviation multiplied by the square root of n, which is what your standard error formula. Based on that, you have what? X is your mean, sample mean. Then mu is your hypothesized or the population mean. Then sigma is the standard deviation and n is the number of sample. So this test is considered robust for the violation of a normal distribution and usually applied when the population mean and the variance are known. The p-value corresponding to the z statistics is less than or chosen than the significance level of 5%. So then we reject the null hypothesis, which means if the p-value is less than 0.05, then it's a alternate hypothesis. And if the p-value is greater than 0.05, then it's a null hypothesis. So it can be concluded that the sample mean are significantly different from the hypothesized mean when there is a alternate hypothesis. So how do we do? Let's say I'll just explain you. So if p-value is greater than 0.05, then it's a null hypothesis, which says there is no difference. And if the p-value you have is less than or equal to 0.05, then we will be saying this is a alternate hypothesis and there is a difference. This is the way we'll be comparing these. So I will be taking the practical example now. How do we do this? Let's open the mini tab and generate some data. Maybe the data I'm generating here in the same. Suppose you are doing some transaction and there is a transaction time. You are doing the transaction between, let's say, from 20 minutes to 25 minutes approximately, or let's say 20 to 30 minutes you are doing the transaction. You have done for last couple of transaction because sample size ideally should be greater than 30. So I'm taking, let's say 35 transaction you have done here. I'm just pasting these as an value and I'm setting up the target because values I have taken 20 to 25 and the client is asking, boss, I can give you that the target value what we have should not be greater than 25 and with a standard deviation I can allow maximum 5 variation. So these are two target you have. You have to meet the target of the mean as well as target of a standard deviation. So as a layman, if I compare, this is your target value. If I compare the actual from this data, so the average value or the mean value of my data is how much? 25.4, a little higher than the target. And the standard deviation of this data, if I see, the standard deviation of this data is 3.07, which is much lesser than the target. So one side I am meeting the target, other side I am not meeting the target. Now I wanted to compare. So these are the mathematical number which will give you a confirm value. But statistics will always come with a range. So now I wanted to compare these with the help of statistics. So prerequisite for this test, your data should be normally distributed. So first thing, I will be checking the normality of this data. Let me open the mini tab. So the normality of the data, how do we check? I just paste this data here in the mini tab. Normality we always check with the help of Anderson-Darling test. If the p-value of Anderson-Darling test is less than 0.05, then data is not normal. And if the p-value of Anderson-Darling test is greater than 0.05, then data is normal. So we will go to the stat, basic statistics, and here is the normality test. Anderson-Darling is selected. You can see here test for normality and double click on your data and just click on it. Okay, and the test is ready. Now, if you look at the p-value is 0.055, little higher than 0.05. So I can consider at 95% confidence level that my data is normally distributed. Done. Now, how to perform the one sample Z test with the given value, like as your mean is 25 and standard deviation is 5. Either I'm meeting the target or not. In the previous example of statistics, when I was explaining you one sample t-test, I explained the fundamental that how exactly the hypothesis we will be comparing. So to understand the basics, please watch the last video of one sample t-test. Now let's do the comparison. Here we go to the stat, basic statistics, and here is the option one sample Z test. We click on this, we select the data. Known standard deviation, we are taking as in 5 as in target. And hypothesis test, we are comparing with the 25 as in mean. Why 5 and 25? I just explained you some time back. Target is 25 average with the standard deviation of 5. So I wanted to compare now. I have put the data. You can go to the graph and what you want to see. Let's say you want to see the histogram of the data. Click on OK and click on OK. Now you look at the data. The very first thing we always see is the p-value. So as per this data, my p-value is 0.636, which means p-value is greater than 0.05. So it's a null hypothesis, and null hypothesis say there is no difference. So where we are checking the difference of the target value and the actual observation, we are checking the difference. So target of 25 and your actual mean is little higher than the 25, but still statistically both are same. Because the range of your 25.40, which is the statistical range, which you call as a confidence interval, is ranging from 23.74 to 27.05, and target of 25 is very much falling within this range. So that's how we conclude this is a null hypothesis. There is no difference. You can see the same thing with the help of histogram, that x bar is your value, and the null hypothesis, what we have having, the target is little less than the actual. But the target and actual both are falling within the same given range what we have. So this is your actual average, and this comes with the confidence interval. Is this confidence interval is what? The average value plus or minus margin of error is confidence interval. So your target value is very much falling within the confidence interval of your actual value. So that's how statistically they are same, and it's closed as a null hypothesis. This is the way we perform the one sample Z test, and this is the importance of one sample Z test. I will see you people in my next session with the rest of the statistical test. Thank you so much for joining.